This integral needs some visualization. So we have the integral from 0 to 1, 0 to 1, and fractional part of y square minus x dx dy. So basically in this problem, first of all you need to know what fractional part is. Fractional part is basically, let's say if we have 2.1, it's defined as the number minus floor function of the number. Yeah. And floor function is an integer like immediately less than x. Let's say if we have 2.1, the immediately less than 2.1, the integer is 2. Let's say if we have minus 0.9, it's minus 1. Yeah. If we have minus 1.1, it's minus 2. Yeah. And let's say if we have 2.9, it's 2. Yeah. And now over here it's 2.1 minus 2, so that's 0.1. This is the fraction part function. And basically the thing that we need to do to solve this problem is try to express fractional part, like how to open up the fractional part. So basically here it's going from 0 to 1. If a number is between 0 to 1, in this case the fractional part will just be the number itself. Yeah, basically because number minus the GIF will be 0. So yeah, that will be the case. But the thing is, this over here, y square minus x, like can be like lies in between greater than minus 1 to 1. Yeah, because y also goes from 0 to 1, x also goes from 0 to 1, so they lie in this range. Yeah, they're different. But the thing is, like whenever it's in between 0 to 1, in that case the fractional part, we can open the fractional part as the number itself. Yeah, y square minus x, because at that case our GIF will just be 0, so minus 0 means y square minus x. But whenever this is in between 0 to minus 1, in that case like fractional part will be this number and minus their GIF is now negative 1. Yeah, so minus negative 1. So this will open up as y square minus x plus 1. So basically we can open up GIF in these two ways depending upon whether y square minus x lies in this range or the other one. So now like we have to basically break the total person. Yeah, our person we need to integrate is from 0 to 1 in the x also, and in the y also from 0 to 1. Yeah, so basically we need to break this person into two regions. One of them where y square minus x lies between 0 to 1, and the other where it lies between minus 1 to 0. Yeah, and then use two different definitions and integrate. So basically now if I plot this graph, y square minus x is equals to 0. Yeah, that will help us. This means y square equals to x, and we know the x equals to y square is graph is something like this. Yeah, we need to also go like this, but that's not needed right now. Okay, so this is our y square minus x equals to 0 graph. Okay, and now above the graph y square minus x is going to be positive. Yeah, basically for the same value of x, y can increase. Over here for the same value of y, x can increase. So over here y square minus x will be negative. Yeah, and they will be between 0 to minus 1. So basically for this range we need to use the definition of y square minus x plus 1. Yeah, and for this range we need to use the definition y square minus x. Yeah, and then like the height of the figure in this range, in this area portion will be y square minus x, and over here this thing. And yeah, so because here's the y square minus x is positive, and over here there's negative. Now I've already told you like the cases. Okay, So but now the question is, how do we like break this area person into these two persons, one of them colored in red and other colored in this. Okay, so now let us try to see that this over here is actually y square is equals to x. Yeah, the graph of y square equals to x. So basically this area over here can be written as basically our x is going from 0 to y square. X is going from 0 to y square and y is going from 0 to 1. 0 to 1. And so dx dy. Okay, x is going from 0 to y square and y is going from 0 to 1. So for every like y over here, x goes from 0 to y square. Over here 0 to y square. So all of these components, like these components are like included. So this was the area, and the height in this will be y square minus x. Okay, so now we are done for this stuff, this over here. Now for the next one, let's use another color. Okay, now for this one, our y goes from 0 to root x. Yeah, 0 to root x, and x goes from 0 to 1. Yeah, okay, for every like x going from 0 to 1, we need to go from 0 to root x. Yeah, 0 to root x, 0 to root x, 0 to root x. So this covers all the area. Yeah, for every single delta x, we go from 0 to root x. So this why this also covers the other region, and our height for this is basically y square minus x plus 1. Yeah, and the reason is I have already told, because over here y square minus x lies from 0 to minus 1. And then okay, so this was for the dy. Yeah, dy, y going from 0 to root x, and then dx. Okay, so now finally we have removed the f of x and like changed the integral into something simpler, and now it's really easy. After making this change, now there's nothing more to do, just solve the problems, and solving part is a lot easier. Yeah, okay, now let's do it. Now it's gonna be fun only. Now it's just y square x minus x square by 2 from 0 to y square, and then dy plus 0 to 1. This is gonna be y cube by 3 minus xy plus y from 0 to root x dx. Okay, now this will be 0 to 1. Now y to the power 4 minus y to the power 4 by 2. So y to the power 4 by 2 dy, and now over here it's x to the power 3 by 2 by 3 minus x to the power 3 by 2 plus x to the power 1 by 2. So x to the power 1 by 2 minus 2 by 3 x to the power 3 by 2. Yeah, now let's integrate a piece of cake. Very easy. So y to the power 5 by 2. And also note that like I have also evaluated this at both y square and 0. At 0 both of them are 0, so that's why I didn't write it. Or also at 0 both of them are 0, so I didn't write it. Please note that. Again, this is from 0 to 1, and x to the power 3 by 2 minus 2 by 3 x to the power 5 by 2 by 5 by 2 from 0 to 1. Now this is 1 by 10 minus 0 plus okay wait, 3 by 2 by 3 by 2. So 2 by 3 minus 0 minus 4 by 15 minus 0 plus 0. Okay, now this is 33 plus 20 minus 6. Oh wait, not 6, 8. Yeah, now 20 minus 5 is 15 by 30. That's 1 by 2, and which is the answer. So we solved this problem. Basically the only thing that needed some effort was to break this area into two different portions, and after that It was easier. It was just some normal algebra, let's say normal calculus. I hope you enjoy the problem. So like do try to visualize the portion and break it into required parts as per needed. You can also try another problem which I have posted in my community. Basically this one, 0 to 1, 0 to 1, g of y minus x dx dy. I think this one is also 1 by 2, I guess. Do try this, and if you are not able to solve, because you can check my community post, and that there's some help. And also like for this to understand this concept, like there are few people in on my community who have been helping me, and let me take their names as well. So Daniel Rosado and Sopna. So thanks to Sopna and Daniel Rosado, 3213. And yeah, look forward to seeing you in the previous upcoming videos too.